Samastangu namaskar. And today we are very excited. Ama sangare Debu Panda achanti je ki kichi week agru ame tangatharu introduction to machine learning upare gote talk sunithile, and we got a lot of response and a lot of interest in this subject. So I'm बहुत excited कि आउ गोटे एबे talk in the same series, which is about introduction to data analytics. So मैं सुनिवा पई आजी देबु पंडांग थारु आमे एबे सुनिया को चाहूचे about data analytics. So Debu Panda bhai, the stage is yours.
Namaskar, everyone. Last time we learned about machine learning. We learned about machine learning or the different types of machine learning, but you can't use machine learning without data, and you actually do machine learning to derive some insight from the data. So I think that's basically what we're going to do is that provide an intro to data analytics. What data analytics? What kind of job roles are there? Or different personas are there? How you can use data analytics in context of machine learning. That's what we're going to do today. Mo ଗୋଟେ poem about data analytics. And I actually, this is very fresh. Few hours old. This child is few hours old. Not even, I did complete, I think, about 1 o'clock last night. So it's like probably 7 hours. And it came to me, it's basically, Nua Janmo Kavita Kahiba. So, Nua Sabda Jodi, Lekhili, Mo computer Pai Kavitati. Nua Sabda Jodi, Lekhili, ମୋ କମ୍ପ୍ୟୁଟର ପାଇଁ କବିତାଟିଏ ମାନେ କବିତା ହଉଛି ପ୍ରୋଗ୍ରାମ ତା ଭିତରେ ଆଙ୍କିଥିଲି କେଡେ ସୁନ୍ଦର ଫୁଲତୋଡ଼ାଟାଏ ତା ନାଁ ଦେଇଥିଲି ଆଲଗୋରିଦମ ଭାବିଥିଲି କମ୍ପ୍ୟୁଟର ମୋ ପ୍ରିୟା ପରି ଖୁସି ହେବ ହେଲେ ଠିକ ପ୍ରିୟା ପରି ରୁଷି କହିଲାନି କିଛି तार अभिमान भरा मुह कहूला मु लुचाउथली तथ्य और सत्यता तथ्य होची डेटा और सत्यता होची ट्रुथ फैक्ट से दिन सिखिली प्रेम और कंप्यूटर पाई मते देबाकू हेबो तथ्य सत्य और ठीक ठीक संख्या माने नंबर्स मो वाणिज्य माने बिजनेस रो इनसाइट माने वाणिज्यर अंतर्दृष्टि पाई मते बुझिबाकू प्रियार मन परी विश्लेषण करिबाकू हेबो तार हृदयर कथा माने बिजनेस रो सेंस रो पाई यू हैव टू अंडरस्टैंड द डेटा आसंतु सिखिबा तथ्य आउ विश्लेषण विद्या माने विश्लेषण विद्या होची डेटा एनालिटिक्स. All right, so let's get started. I'm part of AWS, analytics team. I'm a senior manager of product management in Amazon Redshift, which is part of AWS analytics team. And let's get started. Sorry, you guys able to see my screen?
Yes, but
okay. All right. So what are the different benefits of data analytics? Monisa बहुत स्वार्थपर बिना लाभ पाई के किछि करंते. So semiti for that, data analytics, before we even learn something about data analytics, we need to know what are the benefits are. First is that it can help you improved decision making and also better decision making. If you do not have data, do not have insight to your data, you can't make better decision. It can improve your operations. And if you're a store, and you have to put the right products in your store, and you have to put the most popular product in the right time. So that helps you in efficient operations. It helps you is like in effective marketing. Means if you do not know about your customers, what they think is popular, you cannot do the right marketing. For example, I do not like, I'm not a big fan of sports, but if the marketer is keep on sending me, things about sports, then probably I'm going to just ignore it, remove it. I'm not going to bother to look at it. But if they send me something about machine learning or something, about poetry, then probably I'll be interested. So you have to know the right information before you start marketing. Improved customer service. Like, how do you know whether your customers are happy, whether customers are not leaving your service? So you have to understand all the different data before it can improve your business. So that's basically you have to do data analytics. And pretty much every business segment, I don't know any business segment, whether it is public sector, private sector, utility, any segment where data analytics are not being used. So every business segment, data analytics is being used, whether it is water quality management to gaming. And I'll give you some examples how you can leverage data analytics and different use cases in different segment in a little bit. So this is a thing probably people do not realize, that more data is created now every hour than in an entire year about 20 years back. That means the amount of data that you're producing in this hour was more than for the entire year 20 years back. So there is a lot of data that is getting generated. Even like you're doing video streaming and generating all this data in YouTube, people are joining in. So everybody is generating a lot of data, and then all different kind of data is being generated. So data is everywhere. If you see, data is in operational databases. If you're using an IoT mobile device, or generating data, using an app to do something that is generating either a stream of data, or there are different IoT devices. Like, for example, let's say there is a smart meter in your home for your utility that is generating data, sending in data to your grid. The cable, you are watching different kind of cable, television. So they are generating data because they want to rate which TV serial is popular, all those kind of things. Data is getting generated pretty much everywhere. And all this data goes to your analytics platform. The analytics platform, and there's different kind of data. There you have the data in your operational databases. Operational databases are nothing but, kind of OLTP databases, like when you are buying something to Amazon.com, or you are going and, buying another store like, eBay. So all this, whenever you submit an order, that generates some data. So that goes to your, operational database. And that data is not immediately available for analytics, because you do not want to run a very expensive query in your OLTP databases and slow down your millions of users. So that data get, ETL. I'll come to what ETL is. That's called extract, transform, and load, and get loaded into your analytics platform. Then think about, going to your website. So there are a lot of log data gets generated. So there are different kind of application. They generate a lot of log data, and all those log data are nothing but gold mines for information. And those log data also get streamed to your analytics platform. So you have all different variety of data that you have, and you want to make sense out of those two data. So that data has to be prepared first. That gets loaded. That's basically called transform and load. Either you do transform and load, or your load or transform. This is a new terminology called ELT instead of ETL. So you load the data first and then transform. And then you have data analysts and other people who are sitting, or business people who want to make sense out of this data. So you have the BI and different kind of analytical apps that use this data to gain insight. And then you have the machine learning tool then also make sense out of the data to provide advanced predictive analytics. So we'll learn a little bit more about all these things today. Okay, moving on. So what are the challenges for data analytics? So as you know, the data is everywhere. So you want to make sense of all your data. So data isn't even Twitter feed, people complaining about your service or appreciating your service. So you want to get a sense of, your customer sentiment. There are data in Facebook. There are all different kind of data everywhere about your company. So how do you, mine all those data, collect those data, and then, analyze this data? So there is, as we told, basically, so the amount of data that is being generated is 20 in an hour is 20 times more than what was generated 20 years back. So if you look at this amount of data that is getting generated, so the second challenge is, where do you store? All are different, different kind of data, different format of this data. Storage is like, because you're generating, probably petabytes of data or exabytes of data, and then you need to make sense out of this data. And then, as you told, that all different kind of data are coming and different variety of coming. So there is a problem we call, 3V problem. Is the variety of data, then the velocity where it is coming, because it's coming very fast, because some data are coming, getting streamed. Whenever you millions of users in your website, a lot of log data that is getting generated. Then we have something called volume, that is the storage, the amount of data. So this is 3V problem. So how do you prioritize which data should you use? Because not every data is like, for example, is going to be important for you. So based on your application, what you want to do is that you have to prioritize which data should you consider for your analytics. And then, once you know, okay, these are my data, this is the thing I want to actually consider for my analytics, then how do I make it usable? Because you have, terabytes, petabytes of data, and there are hundreds of users. Like probably in 5-10 years back, the only users that were using the analytics are the BI platform guys, or the BI developers building the dashboard for some CEO or CXO, any of the big at the top level people. But now there are all different kind of personas that use this data. So, and then how do you make this data available to them? How do you do, for them to use? So those are the challenges for data analytics. So then, because of this, organizations are using something called data lake strategy for storing and processing in the data. So in a data lake, this is an example of AWS data lake that we have. But it's kind of more generic term that I have put there. So you have all different kind of data might be coming in, like JSON or Parquet or ORC format. You want to make sense of this data, do some ad hoc analytics on this data. So that might go to your big data processing platform. There are log data that is coming in, access logs and other logs data that you want to just process this data. So there is a log analytics platform that you have. Then you have, more business sense of, type of, tabular data, or even, the data warehousing platform, like my product, like Amazon Redshift, extends your data warehouse to the data lake. That means basically all the data that is in your data lake that you're storing in S platform like S3 or simple storage system, which is nothing but a file system kind of, that can be leveraged, from all different of these products. So it kind of allows you to query the data, even if the data is stored in Parquet format or JSON format. You can still run SQL queries directly from your data warehousing platform, like Redshift, without having to load that data in Redshift. And then, the same data can be leveraged by your machine learning platform, like SageMaker. And this data can be loaded to your relational platform, like Amazon Aurora or RDS. I'm just giving an example of Oracle, Amazon's product, but there are multitude of products in different cloud providers, and if you want, you're using on-premises platform. But what customers are adopting is a data lake strategy, so that they can store and then process their fast based on what data they need faster. So I think many people fail to understand this is not a one-time process, but it's a continuum. Because every day I hear from customers, okay, I want to process this new kind of data. There is a new format that has emerged. How do I do this? So it's a continuum process of the business leaders wanting to make sense out of this data. Then how do they make sense out of the data? Because the data analysts, data scientists, and data engineers, they or ML engineers, they want to build, machine learning platform, machine learning models, or build dashboards, or their ad hoc analytics, whatever they're doing with SQL. They want to get sense out of this data, and they cannot make sense out of this data if the data is not stored in your, right analytics platform, and it is not available to them in the right format, or in the right, not prepared for that. So the data engineers are always working on, struggling on, how do we make sense of this data, make it available. So there are the different personas that I'm going to talk about, that is very, very interesting or emerging, for the last several years, and it's going to be popular. And my next slide, I have a little bit more about these personas, and that might be interesting for you. So the data engineers are a kind of more engineering role. So they prepare and load their data for others' consumption. That means they are not the consumers. So these guys actually build their, the pipeline, or you can say the ETL platform, or the complete architecture for the ETL platform, to bring different data from different, sources, load into the analytics platform, make it ready, or transform the data for the other consumers to use it. And for this job, you need some strong technical engineering skills, like in databases, big data platform, like Hadoop, Apache Spark, or and then programming languages like Python, Java, or then SQL. And this is primarily data warehousing, ETL, pipelines, analytics platforms. So there are tools like Amazon Redshift, or Snowflake, or BigQuery, or Databricks. All these different different technology and platform. You need to learn to be a data engineer. Then so this this more engineering role, and this is emerging, and this is the job. The title gets changed, but and this is probably the right title, the data engineer, because these guys make available. But several years back, you used to call ETL developer, And before that, they used to call, more database developers. So, but this is a job role. I have been thinking that, okay, so go away next, 5 years and everything will be automated. But this is a job role that keeps on, evolving and pretty popular, and highly paid job that in organizations. Then the data analyst. So the data analyst, have to be passionate about the data. They need to know a specific domain. Like, for example, there are data analytics in healthcare. There are different data science jobs like computational biology and bioinformatics. They are, that kind of merges, the data analyst skills with, the skills in healthcare industry or more bio-related industry. So the data analyst, analyzes all the data in your analytics platform and, help the organizations make, better decisions. And this is a person, who is very, very passionate about the data and have to understand their business domain. So this is not like just SQL and you can become a data analytics guy or data analyst, but you need to know about the domain well before you can be a good, successful data analyst. And these guys do not have to be as technical as the data engineers, but they have to know SQL database and some scripting like R or Python well before it can be, because there are a lot sometimes in the data you have to summarize, aggregate, so you need to know a little bit of other scripting language to be successful. The guys, there are different forms of data analyst, you can say. Some guys just deal with writing some very high end, like I've seen some people writing like 300 lines SQL, which I can't understand without understanding that domain. It's very, very sophisticated SQL they write. And many of the organizations, they have different form called BI professionals. So they or BI developers, they actually build dashboards. Earlier, most of the people were, just the way they were consuming their data as a form of a dashboard, whether it's a Tableau dashboards or Amazon QuickSight dashboard or, or Power BI dashboard from Microsoft. So many of these guys actually build dashboards for other organizations to gain insight from this data. Then the data scientists. So they are the guys, know more, about not only about the data in the organization. So you can say, the computational biologists and bioinformatics guys, they use machine learning with their bio data, for example. They're data scientists in financial industry. They understand, they try to predict whether whether my stock is going to go up or not, but very difficult task, whenever and then whether my revenue is going to go up or my number of customers are going to churn. All these different kind of use cases are there, and these are the guys actually, they use machine learning algorithms, and then they do not build generally, new machine learning algorithms, but they leverage the machine learning platform that is available to them. But they understand, the machine learning concepts and deep learning very well. They are proficient in either Python and R programming languages. They use SQL to retrieve the data, analyze this data, and generally more advanced statistical and analytical skills are required for this job. And then there are there are other jobs also in like for example ML engineer. So the guys they make sure that the ML platform is available. And then ML ops, what people are is emerging. So ML ops is like, for example, once you deploy your machine learning platform and and then it's running. So make sure that what is running, whether you are getting the right score from from your prediction, and then the training is retraining is happening. All those kind of things are different machine learning platforms are available, and the ML ops people make sure that these are up up and running, and then people are able to derive insight from the machine learning platform. But these are the key things that I see pretty much every organizations, and there is a lot of hiring in for the different roles. Okay, as data is everywhere. So where which different kind of jobs fit? Basically, this is a kind of I try to put there. The data engineer are the guys who try to put the data from the operational systems, or leverage the API, or from the IoT or mobile devices or streams from to load this data. And then the data analysts basically use SQL or other tools like BI tools, to leverage to make insight of that data. And the data scientists, use the data analytics platform to for their test data, training data, and help build the predictions from that data. All right. So now that we know, what is, data analytics is, let's look at like what are the type of data analysis. So there are, it's not data analysis is one thing, but there are 4 different types. There are people subdivide again into some of this area, but to me, there are 4 different types of data analytics or data analysis. You have one is a descriptive. The second one is diagnostics. Third thing is predictive, and fourth thing is prescriptive. So we'll learn a little bit more about this. So the descriptive analysis, helps organizations, you can say, to make data-driven decision better. Really, what is happening in my business? Like what is the revenue of for my product for the last month? How many users signed up for this this month or today? Or how many page views did we have today or this week? What is the percentage of growth year over year? So is all this kind of different thing you can derive from the data. And in order to make sense of this data, you have to define a metric or a measure, what we, or sometimes we call key performance indicator. That means wow is thing. So as like, for example, as a product manager, whenever I'm launching a product, first thing I want to I basically do is that define is that what are the metrics I want to measure for the success of the product. Like, for example, okay, whether there's a number of users, daily number of users those are using, or weekly number of users, whether there is a user growth from this week to next week, whether this product is actually impacting my revenue of my product, whether this, how many, first thing is that users, and then the customers. Customers and users are different in the sense, there might be 5 different companies. So those are customers. And each company might have, let's say, for example, 10 users. So they're all individual identity, like Debu Panda, Anjan Panda, and others are all these individual people. Where customer is a company, that's from, if you're an enterprise company, and then you're focusing on your business. So I want to understand whether more number of customers are signing up for this feature. Whether what is the engagement rate for this feature? That means people are just trying out and leaving, or they are actually using on a daily basis, like what is the daily active customers. So these are the kind of thing to define what you want to measure for this before even you launch a product. And that's the data thinking process that has happened in the industry. If you're running anything in the cloud, from day one, you know whether your product is being used or not. Because whenever you are launching a product that comes with some metrics, so you might have been using, some of the app, like for example, in your iPhone or your on your, let's say, any other mobile platform. So what happens is that, all this app actually sends data to the server. So you might have seen like a option that, okay, do you want to send your data anonymously for improving the experience of your product? And Facebook usually used to collect all this data from your mobile platform or about you. So all the apps, collect all this data, even without asking you. Sometimes they make this as a default, and sometimes they ask you to opt in. So all this our data is coming because, so the product manager like me has defined, okay, I want to see this data. And, even if you do not provide this data, like when you go to a website like google.com, or, even, small companies are on a website. So each of your interaction generates a log called access log. And that log file has a wealth of information, so that customers can track. Like, for example, it has your IP address. If you're working from home, you have your IP address, which is provided by ISP, and from there, we can do geo analysis and tell actually which city you're coming from, whether you're coming from Seattle or San Francisco. You can know about this. Whenever you're logging in, it gives you a user ID to a website, that has information about your log, which, user is. It has information about what browser you're using, whether you got an error or your website, your web request was successful. It has a status code, like 200 is successful, like the 500, 400, like it's for an error, internal error. There are, like, for example, permissions error, you might get like 400 to, 402, 40, like all the different kind of error code are defined in the HTTP process. So all, like, even if you just open, I just put an example of a, web access log here. So this, if you look at, all different kind of logs are there. So if you just look and start looking at the log, you can know, how many number of users, distinct user actually came to my site by looking at the names. Scott, Debu, and Panda are 3 different users. There are 3 users came, but you cannot, manually process when you have, millions of users or hundreds of, even like hundreds of users, because generates like every request. Like, for example, if you have a complex page, and complex page has like 5 different images and 5 different JavaScript, all those are separate requests, and you can see like millions of or billions of rows. You cannot manually process this data, to gain insight. So you need an analytics platform to process this data. So, but, when you take this data and you can build a dashboard like this, just from that data. If you see here, how many number of hits I had, it's based on the number of, page hits by just counting the, for a specific page, you just count, like the request will not have, for example, .jsp or ASP. You can tell your HTML and you can count that, all those distinctive, and tell how many number of hits you have. If you look at like the graph below, there's a geo chart or geographical chart. You see this where the users are coming from. That the red circle that you have, and actually you can show that if it is a bigger circle, that means more number of users. Is red means people are having issues. You can put this in green. All this kind of thing. There are tools they're building, and then like for example, on Amazon's open search product, or Splunk, all those are different products that can help you, the open source Elasticsearch and OpenSearch and Kibana. Kibana is the dashboard platform for that. So you can use all this data to gain insight. And this data you can leverage also to identify problems. So as a part of this, I have, like, for example, the log analytics. This kind of gives you one part of that, log analytics. So log analytics, a lot of customers use in real time to identify what is happening. But you cannot manually do this. You need to have hundreds of, for example, servers. If you have millions of users coming in, on how do you process this data, how do you analyze this data, because and you cannot run a real-time dashboard on hundreds of millions of data, log data directly. So you probably sometime mine it to understand what happened in the last 1 month by preparing this data, loading into your data warehouse, and then analyzing in a tool like Tableau or Amazon QuickSight. So we'll show some examples for that. So this is a traditional, what we call is ETL. So as we have different kind of data coming in different places, and also we have OLTP data, like let's say whenever you're making transactions in your application, and then there might be different kind of databases which stores different kind of transactions. But when you want to make sense out of the data, for example, let's say whether you have customer ticket information in one database, and that, and then the other database has your sales information, and you want to make sense of all this data together, because there might be thing is that when the number of customer cases are going up, your sales is going down. That means because there is a problem in your website, problem in your product, customer satisfaction is not good. That's the basically future product sales are not happening. So all these are different in different kind of databases. So what you want to do is that you want to ETL or extract the data from your online processing OLTP database, and then you load into your data warehouse. And sometimes you cannot transform earlier, because let's say you want to join this data. You join, load the data in your data warehouse. We call this ELT. You transform the data after loading, rather than fast transforming the data. And there are different ETL platform that are like company like Informatica. There is Amazon has AWS Glue. So all these different kind of tools are available to do your ETL, to make it ETL simpler. Many customers, they want to write everything from scratch using, like, for example, Amazon's and data API and AWS Lambda and other. But not every organization has all right skills or right skills within their data engineer, and they don't want to reinvent the wheel. So there are ETL platforms that customers use to build their ETL for their specific organization. So to load this data and transform the data. So this is an example that that my product, like I have a product called Data API, how customers actually use this to write event-based ETL. That means basically, let's say some data gets loaded into a bucket or a folder in S3, which is S3 is Amazon's simple storage service. You can just load the data, and the data gets automatically loaded into Amazon Redshift using Redshift Data API. So people write their code using AWS step functions, and orchestrate their ETL workflow by writing some code. But this is the work of a data engineer. Data engineering job is very fascinating and interesting if you want to do something in the data space. The other thing is that when you load your data into your analytics platform or your data warehouse, you do not want to, is basically denormalized form. That means basically when you have your data in the operational data warehouse, those are typically what we call normalized. So unfortunately, I do not have time to explain what not data normalization in relational databases are, but they are structured in such a way that you do not have problem in acid. With the terminology of acid is atomicity, consistency, integrity, and integrity problem in your data. So the tables are structured in such a way that it's very optimal and do not have acid problem. So, but when you are loading your data, you do not want to join several tables and slow down your system, because you are not, and people do not have insert or any kind of privileges on your analytics platform. They're just running queries to make sense out of the data. So what we do is something called denormalized data, so that is faster. So when you do this with it, so customers follow a standard convention called star schema. So the star schema is nothing but is a way to create your data format where if you look at sales is the facts table, or that has all the different kind of measures. Like if you see unit sold is basically number of things that got sold. That is your measure or the metric that you want to measuring. Same thing, dollar sold, dollar cost. All these things are are different measures in your fact table. And the other table that on your stars are like product, period, and store. These are all reference data we call dimension. So like, for example, you want to analyze this data, it's much easier to find out, okay, tell me which is the top 10 product code, and find the, or a product code with like, which is my most popular, t-shirt and size of the t-shirt, by sales. So it will becomes much easier to join this data to derive insight. But each of this slide is in probably in 1 hour presentation. Unfortunately, you do not have time. Maybe if there is a lot of interest, you can go dive deeper into each one of these topics. But I think all the information is available in YouTube and other places. If you want to deep dive, So let's look at how to analyze your data with SQL. So I'll just go to my browser here. Make sure that I'm not timed out. Okay, so not timed out. So let me just reload my. Okay, so if you see here, they are all different. So I'm connected to a data warehouse, Redshift data warehouse. So here I have different databases, and then if I, expand to a database, I'll see different schemas. So I have different schemas here, like TP-CDS, and I have, in a schemas, I see different tables. I can expand my table and like, for example, look at specific tables, description and, and then like, for example, run queries. So here, so what I have done is that I have written some sample query for you to. So if you see here, what I'm doing is, I'm writing SQL. So you have to know SQL to be a data analyst, as I said, like, and pretty much even now, SQL is a popular language for NoSQL platform. If you look at HDFS and, people build, the Hadoop platform, but, Apache Spark is probably the most popular, interface to write, to gain insight from the Hadoop platform too. So it's kind of, if you see here, I have written different skill, and if you see here, I have like my store sales is my fact tables, and store returns are my fact tables. And then all these are my, catalog sales is also my fact table. And these are my different dimensions table. The date is my dimension table, store is my, and items are. So this I'm basically is joining multiple tables, and getting the data from here and joining multiple tables. And here I have like tens of SQL that I've written for analysis. And this is actually so all different individual SQL, but I see people running, like hundreds of. So I got timed out close line. Okay. Okay, let me connect to my. Okay, let me run my SQL. So if you see run, because I ran the SQL a little bit earlier, so it came out very fast. So if you see, these are my different data that I have. But if I do not understand this data, so it's very, very difficult for me to understand what this is, the monthly sales, but you need, to first have understanding of the data. You can write great SQL, but that becomes useless unless you understand the data and the relations of the data. So as a data analyst, you need to understand your data, and then what a lot of data analysts also play a lot with with Excel. So they export their data from here, from their SQL platform, and then they try to do visual analysis. But modern tools like us, actually, we are trying to provide them ability to do visual analysis inside, so that they do not have to depend on a third-party platform. For example, I want to see different data by store name, and I want to say, let's say, average month sales. So you have to take this data out and then export this and then put this in Excel and do a visual analysis. But you can do simple visual analysis from here, so that you can understand the data. Because sometimes what we call is a picture is worth 1,000 words. So sometimes it's like, for example, if I want to give my data to my my CEO or VP, it's much easier to send this graph, because that's how you also easily send. This group has, this store has 150K revenue today. So it's like you can easily understand. You can add y-axis, and share this with your user. But again, there's a simple way a data analyst, you can run some queries, do visual analysis, and see, gain insight from your data. So let me go back to my PowerPoint again. So again, like, so when you, let me go to the next slide then, and I'll come back to this. So the descriptive analysis that we saw kind of help you analyze, what your business is happening. But assume that, you might be, I don't know, sometime we ask, whenever you're going to an interview, we tell, okay, think about you are the CEO of the company of a startup, and or you're a product manager, or you're a data scientist, or this job role. Think about, your boss comes and tells you that, okay, you told me that our revenue went down yesterday by 20%. Tell me why this is happening. Why my revenue went down last month? Why my user registration fall last month? Or why did my page views went up dramatically? Why my sales went up? This question basically is answered by something called diagnostics analysis. So there are different kind of diagnostics. So there are You can diagnose the problems in your website by looking at, whether you're getting a lot of 500 errors, but, you cannot correlate directly for, by looking at all those 500 errors in your website for the last 1 month by running this query like this. So you have to summarize this data, put it in your analytics platform so that you know that this many number of 500 errors you got, or people who are not able to log in, or whatever makes sense from a business perspective. And then you try to identify the problem running different kind of queries, correlating this data, and then help identify what could be the problem. We call it a diagnostics analysis. So you can, like for example, I have a dashboard here. I want to quickly show you. So this is the dashboard that I built. You can see different kind of data, in the history, and you can see there is a bump in my, the number of deals that I lost. Okay, so you can actually try to correlate with other things, like whether this is the deals were qualified, or whether whether the deals that was running was somebody else. But before when you go to the business data, so what I want to show you is that what do you call, we call it a dashboard. So this is like the data analyst, or that build we call this. If you look at the different kind of metrics that I have, and pretty much every BI tool provide this kind of capability. So this is, I'm using Amazon QuickSight. This is our product, but you have tools like Tableau, and if you look at this kind of dashboard becomes very, very popular during the pandemic. Every county, every state was putting this kind of dashboard during the pandemic, showing how many number of cases, whether the cases went up, COVID cases went up, whether number of deaths increased, hospitalization increased, all the different kind of information. People are providing this so that their citizens knew about what is happening in the pandemic. So you can actually build this kind of dashboard by leveraging the data that your data engineer provided, and sometimes the SQL, and you can actually run that kind of SQL, create a data source, and then build a dashboard like this. And this is generally, a tool that you can learn very easily. So if you know SQL, your data, and a little bit of database technology, like how that means basically how the tables are joined with each other, you can easily learn a tool like Tableau or QuickSight to build your dashboard. And each of your visualization might come from the same data or different kind of data based on what is your business need. For example, here I'm showing the historical opportunity pipeline, and then I have pipeline by revenue, projected weighted revenue, and then how many number of opportunities by what stage, all the different kind of data that I have. So this a sales leader can look at and quickly find out what is happening. So and also sometimes you can visually correlate different kind of data by analyzing this data that helps you to identify a problem in your business. Like is my so if I build a dashboard, for example, here by leveraging the data from my customer tickets and my revenue, or the number of customers lost, then I can easily correlate. Okay, last month a lot of bugs were introduced. That's the reason, basically, number of engagements went down, and because of that, this month I don't see a lot of revenue. So you can actually correlate this kind of data from different sources to help identify diagnose what is happening in your business, what is happening, like you guys do, troubleshooting methodology and tool in your code or your program to identify for diagnostics. Similarly, we call diagnostics analysis. Okay, so let's go again. What you call is predictive analysis. So you told your boss that my revenue is going up or going down and went down like 20% this month. So he might likely ask, what is going to happen, this month? It is still going to go down or going to go up? What is, whether, how many number of users are going to churn this month? How many number of products are going to be, popular this holiday season? Which products should I recommend? Like, for example, if I am buying something, from a website, then you might have seen, okay, you might like this. So all those are, nothing but predictive analytics. So you need to use, some kind of advanced statistics or simple machine learning algorithm to derive, predictive analytics from your data. So I think next time I'm going to demonstrate how you can use, predictive analytics with your application, how you can build a simple machine learning model, and make it, give it to your, even the data analyst who can run this, from SQL to predictive analytics. So I can, so that's, predictive analytics. How you can derive, use simple machine learning mechanism to identify what is going to happen in my business next month. And then everybody's interested. And this is, is getting very popular now. Then, and in order to use, machine learning and predictive analytics, people, you not only use, machine learning, algorithm, but what we have something called a Jupyter notebook. Jupyter notebook allows you to, and then there are also a Zeppelin notebook. These notebooks are actually allows you to have different cells, and where in each of the cell, for example, you can have a different type of application code. Like, for example, Zeppelin allows you to have, R code from R and Python, SQL, all the different kind of code that you can write. In Jupyter, it allows you only to have one specific, runtime engine. That means the runtime could be either Python or R or whatever using, but most people use Python with Jupyter because it evolved from something called IPython framework. But it allows you to build visualizations on the top of that. So, like, for example, I'm saying here, so this kind of example of predictive analytics, how is going to, on the left side, whatever you see is the actual data, historical data, and right side where you see this kind of blue highlight there. So this is nothing but what is likely going to happen in future. And you can build a machine learning model and use that for predictive analytics. The next one is prescriptive analytics. That means what should I do? Because my revenue is going to go down 20% as per my predictive analytics. So I have to take some action to improve my my business. So what I have to do? Which sales campaign should my sales team should focus on? Because I cannot focus on every sales campaign. I want to be targeting to the right guys. And the holiday season is coming. I have limited storage. I have limited budget to purchase product. I need to buy the right product for the holiday season. What I have to do? How do you cite my positions? How do I hedge them? Or, whether I need to place trades in my, in my stock. So these traits. So this is like all kind of things, we call it prescriptive analytics. And again, this is need to use machine learning. And as we discussed earlier, why you need to learn about, data analytics, because they are the things you need to know. You have to understand the data before you can apply machine learning. With that, let's summarize this session today. There is a large amount of data that's got generated, and as organizations focus on their profitability, their existence, so they need to gain insight of this data so that they can take better decisions. They can improve their business operations. They can improve customer service or many other things. And the data analytics is very, very interesting areas, and it is now very popular field. Pretty much every business segment, there are different kind of job roles, like data engineers to data scientists. That you guys can take a look if you are looking for a job, or you are a student. If you don't want to become a software engineer, there are all the different kind of job roles available. And then the prescriptive and the predictive data analysis leverages some form from machine learning. With that, I'll conclude this session, and next time what we'll do is that basically I'll show you a simple example of how you can use predictive analytics using machine learning. And I'll show you this from how you can do this directly from SQL before we move on to how you can build machine learning, and then discuss about how to prepare data for have to have the right machine learning. All right, with that I'll stop sharing my screen.
Thank you so much, Deepu bhai. बहुत interesting session. I'm sure बहुत समस्त जे join करचंती और जे YouTube रे देखुचंती बहुत किछि यूजफुल शिखिया को और जानिया को मिलिथिबो. एबे आमे किछि समय spend करिवा maybe couple of minutes or at max 4 to 5 minutes for questions. If there are any questions, feel free to put them on the chat, or you can also unmute. Actually, in the meantime, more out of curiosity, got a question thila. सेटा हला कि आपण जो describe कले data analysis करिया पे visualization, I think that is a very under estimate, like underrated part of the whole process. I directly follow using the data in a machine learning pipeline before actually visualizing it. Yeah. So that is great. I'm just wondering कि जदि हम पाखे आपण जो examples दले से counts थिला, number of something happening, or counts, or the number of likes or comments, for example, in a social media, for example. But the data can come in other forms as well, like image data or video or text data. So what are your thoughts on analyzing those kinds of data?
Yeah, so I think the main thing is that whenever you're doing data analytics, it has to be transformed into numbers somehow. That has to be somehow processed into numbers, because sometimes like people write bad, let's say in Twitter feed, write in text, bad thing about about your product or your company. So that has to be processed and in a form so that people, computer can understand. Even machine learning, whenever you're doing any kind of analysis, it has to be numbers at the end. You have to process that. Computer do not have any kind of emotions. It understands only numbers at the end. And same thing is that whether there, whenever there's like people have, like for example, let's think about sentiment analysis about your product. they come, then all these things comes at text, but somehow the text has to be processed and converted into numbers. So whether the feedback was very bad, what kind of words this can used, whether it was a product issue versus whether it was a service issue. Computer will not understand unless you convert that into. So there is that is also part of your data preparation phase. So when you take this kind of data for data analysis, all these people are writing, like for example, all the Twitter feeds, people are nothing but coming as streams. They take the Twitter feed and convert into these numbers so that you can analyze this data. So what is something like some people will basically call something, let's say for the text data analysis, they build a dashboard called word cloud. That means which kind of words are used, how much. So if you want to know that, but people more care about like how many people are talking about this. So there is, if it is a one comment, that can be one person might have a bad experience. But what you probably want to know is that whether hundreds or thousands of people are talking about the same thing. That means there is a real problem in your product. So you need to understand. So at the end, it's the numbers that count. We care about our salary, bonus, how many people care about Are Baba, bhala kama kalu. You probably don't care. Oh, my manager kaila, but this is like mitha katha kauchi. At the end, everybody is materialistic, and then all these numbers actually come.
I'll jahar bhi audience re kichhi questions achi, feel free to ask.
अंजन मु गोटे सुनील कहूँ सुनील भाई गोटे कथा ऐड करने चाहूँगी कि जो क्वेश्चन था कि ओके हमर टेक्स्ट आसी इमेज आसी आमे कोन करबा राइट तो मु तो माइक्रोसॉफ्ट अच्छी मु तो डेटा इंटीग्रेशन अच्छी तो मु गोटे यूज केस कहूँ जोड़ी कि जो देबू कहले कि जो ऑर्केस्ट्रेशन इट इज सो इम्पोर्टेंट राइट फॉर ए डेटा इंजीनियर टू नो कारण मु गोटे कस्टमर यूज केस कहूँ से माने तमरो टेक्स्ट डेटा आनुचंती राइट टेराबाइट्स पेटाबाइट्स ऑफ डेटा राइट ताकू से माने एकेएस इंजन माने जो हमर एजर हमर जो कंटेनर सर्विस राइट इन कुबरनेटिस ताइरे एनालाइज करी कि इमीडिएटली विद इन 2 मिनिट्स सेही टू जो वर्ड क्लाउड कहले देबो राइट से सब एनालिसिस करी से डेटा आनी ताकू पुनी वेयरहाउस डेटा कुड बी रेडशिफ्ट और कुड बी आवर सिनैप्स डजंट मैटर ताइरे एनालाइज करी कि इमीडिएटली रिपोर्ट टू एग्जीक्यूटिव्स विद इन 3 मिनिट्स दे आर एबल टू डू इट
and actually the container technology and the cloud is enabling, because you cannot have this kind of computing power inside your company. So but because it's pay for use, the cloud cloud as Sunil bhai kahle cloud rachi, and then containers are cheap, very cheap, and then depends upon you can go and come. Like for example, you send an email to Google, you reply something, it can on the back end actually creates a container for you.
Okay. I'll jahar bhi kichhi question achi, if or even if you want to just say something.
I would kotha कहबी I Debu will agree with me. AWS में Microsoft अच्छी मु देखुची मु तम सब हम तो we are getting old right मु देखुची हमर जो नुआ हमर ओडिया इंजीनियर मन आछुंत राइट आई एम टॉकिंग अबाउट ओडिया हियर ओके सो मु देखुची समने 3-4 वर्ष काम करचंती they want to land into a big project, big MNC project on a data engineer project, right? किंतु सेमाने पर concept basics, right? Basics like writing complex SQL or writing Python or system design or केमिति सब end to end काम करे से knowledge नहीं बुझलो से मुताबर मु देखुची हमर जो बड़ सिस्टम इंटीग्रेटर्स अछंती सब अछंती राइट से माने खाली they place people without proper training on the job केते सिखिबो again that's what I have found kintu mu kon kuchi but it's again for Odia ML engineers if you have some basic training basic case studies, right? Hands-on experience, right? You can connect to what they would talk very easily. So that would really help. Okay.
Yeah. I think I agree with Sunil bhai. I think the first thing is that many people, I get a lot of things that they want to use ML. The first thing is that, find a use case for me for ML, or, a lot of, I get a lot of LinkedIn, can I find a job in ML? But as basically ML is just a means to the end. It's not an end. So it helps you solve some analytics problem, So there was I think Vivek Babu raised hand there. So I think Vivek, nice to see you.
Namaskar.
Namaskar. How are you?
Good. So first thing is, I joined a little late. Sorry for that. I couldn't imagine that, I lost first 15-20 minutes of the session actually. So Devuda, just for your knowledge, I worked on data analytics and data engineering a bit, even though I'm not a very technical person. But I've never explored anything towards the AWS side actually, and I really looking forward to, look into your session. If you could provide any of the links, probably Redshift is the new thing which I was trying to look forward. I saw those graphics which look really good, better than Tableau and all other products, I think, right? So if you could guide me on a few other things, how to start, probably I'll explore more into that session.
Yeah, I'll basically, I didn't want to make it a product pitch, so I want to be more generic. If you guys want to go a specific topic, like for example, Redshift or in like, QuickSight or even Sunil Bhai is there if somebody wants to go, about Synapse and all. So you can do, more product specific training. Yeah, I can definitely, if you send me an email, debupanda@gmail, I'll send you more information.
I'll do that. Thank you.
Okay.
Thank you so much, Vivek bhai. And yes, one thing jota mention hela tike aguru ki seta I think it's also hands-on experience is also important in addition to learning about the concepts and skill set seithru hi develop haba. How in the last minute we are already running like overtime. But anybody wants to introduce themselves or say something about it, so feel free. Otherwise, mu author thank you kahibi Debu Panda bhainku, and we are actually looking forward to the next session. Now it's at that stage ki bahut exciting hi jaichi. We are really looking forward to the next session, and until next time, thank you again, and I'm able live stream end kariba Abhijit bhai.
All right, thanks everyone. So see you the next time.
Thank you for organizing. Bye.
Bye.
Thank you. Bye.